All right, this is Professor Pelt. This is part 3 of chapter 1, section 3. Now we want to deal with the fractional exponent. So if you have a fractional exponent, it's the same as the equivalent as the radical, essentially. So a third root is essentially, let's put a better x into there, is essentially x to the 1/3, right? That's the equivalent. And if you have a negative exponent, you need to flip it, essentially, is what the rule is saying. And equivalently, if you have a fractional exponent, okay, there's two ways of doing it, okay? You can put the exponent on the outside or the exponent on the inside. It's up to you depending on the pretenses. Either way, if it's negative, you need to apply the negative first to flip it, essentially. Okay, and be careful as to what the negative actually applies to, whether it's the exponent or the number or not. If the exponent applies as a number, let's try some examples. Okay, so what I really have here is 125 to the 1/3 power, or exponent, right? But I don't know what that is in my head, so I can rewrite it in exponent notation. So that's the third root of 125. So that is the third root. So it's really 125 to the first power, but we don't need to write the first power. It's not really necessary, right? So this is 5 times 5 times 5, correct? Because 25 times 5 is 125. So what you notice about all these lessons I've been doing here is knowing your divisibility rules is of essential importance. So I have 3 of these, so the answer is 5. Okay, so the next one, this is negative fourth roots of 16. You're like, well, the 16 is negative. Well, no, because if I have like 5 minus 16 to the 1/4, right? You have to remember that the exponent comes first, the subtraction comes after. So if there was parentheses, it would make a difference as far as whether the exponent applied to the negative or not. It does not in this case. You follow the order of operations. Okay, so this is negative fourth roots of 2, 2, 2, 2, right? We have 4 2's because 4 times 4 is 16. So the answer is negative 2. Okay, so the next two, this is the third root of 27, right, to the second power. So remember there's two rules. I can put the exponent of 2 in the inside or the outside. My preference is almost always to put it on the outside. Unless I'm trying to cancel some kind of negative on the inside. So this is the third root of 3, 3, 3 to the second power, because 27 is 9 times 3. So this gives me 3 squared, because there are 3 of these, so that groups up, right? So that gives me an answer of 9, because 3 squared is 9. Okay, last one. So this is negative fourth roots of 81 to the third power, right? Because the exponent only applies to the 81. So this is negative fourth roots of 81 is 9 times 9, which is 3, 3, 3, 3, 3. 9 times 9 is 81, correct? So this gives me negative 3 to the third, right? Because there's 4 of these. 3 to the third is 27, so this is negative 27. Okay, pause the video, try the student problems for yourself. Okay, student problems, there's a negative exponent here. We need to account for that first. So this is 1 over 27 to the 1/3, right? Which is really 1 over the third root of 27, which is really 1 over the third root of 3, 3, 3, right? There's 3 of those, so that's 1/3 is actually the answer because there's 3 of those, right? Okay, so 64 to the 1/3 is the third root of 64. So if I break that up, 64 is 8 and 8, which is 2, 2, 2, and 2, 2, 2, right? Because 8 is 2 times 2 times 2, correct? 8 times 8 is 64. So I have 3 of those and 3 of those. So that's really the third root of 2 to the third times 2 to the third, if you think about it. So 2 times 2, and the answer is 4. So there's nothing left in the inside. It's a perfect one. Ah, it's a terrible 4. Let's try that again. Okay. I think we're good there. All right, negative exponent again. To apply that first, that's 1 over 32 to the 2/5. So if we rewrite this, this is 1 over the fifth root of 32 and square it. So if I rewrite this, this is 1 over the fifth root of 32, which is 4 times 8. So that's 4, and that's 8, right? All to the second power. Well, I have 5 of these, don't I? So that's 1 over 2 to the second power, because the fifth root of all those 2's is 2. So that gives me 1/4 is the answer, right? 1/4. Let's make a better 2/5 than that. That's not very good. There we go. Okay, last one. Then we have the square root of 4 to the third power. The square root of 4 is 2. So 2 to the third power is 8. Okay. All right. So that's fractional exponents, whether they're positive or negative, whether there's a 1 or not. Because again, if there's a 1, you just put a 1 like this 16 one up here and B in the top. Okay. So let's do so with variables now. And the question is, what changes? Well, really nothing. It's still the same rules. This is still a product rule, right? So this is still 5 times 7 times x to the 1/2 times x to the 3/4, right? So 5 times 7 is 35. So this is x to the 2/4 times x to the 3/4, right? Now I have common denominators because the rule states you have to add exponents when it's a product rule, right? So I really have x to the 5/4, right? Which, it's not a very good 4. Let's fix that. Right? All right, so 1 1/4 if you have 1 1/2 in there, kind of makes sense. All right, so next one. So 32 divided by 16 is 2, correct? Then you have x to the 5/3 minus 3/4 because the quotient rule says subtract exponents, right? But those are not common denominators, right? So I have x to the common denominator is what? 12. So times 4 is 20/12, right? Right? If I times it by 4. If I times it by 3, that's 9/12, correct? So 20/12 minus 9/12 is 2x to the, let's see, 20 minus 9 is 11/12. There we go. Okay, and the last one, we can rewrite this into the other form. This is x to the 3/9, right? Because that is the numerator and that is the denominator, right? You can always think of it this way. The exponent makes you larger, right? And then the radical makes you smaller, I guess. So the denominator makes you smaller. So this is really x to the 1/3 and be the equivalent. Okay, pause the video. Try the student problems for yourself. Okay, so this is the product rules. This is 2 times 5 times x to the 4/3 times x to the 8/3. So 2 times 5 is 10. We have to add exponents in a product rule. So 8 and 4 is what, 12? But 12 divided by 3 is 4, so that's 10 to the 4th, right? When we divide those. Okay, so next one is a quotient rule. So we have 20. I'm sorry, not 20. I didn't do the math. 20 divided by 5 is 4. And then 4 minus 3/2, because it's a quotient rule, we have to subtract. So this is 4x. So if I do times 2, that's 8/2 is 4 minus 3/2. So that's 4x to the 5/2. There we go. And lastly, let's rewrite the formats. This is x to the 3/6, right? We're going from radical, so this is radical notation. This is exponent notation, right? So this is really x to the 1/2 once we simplify. Okay, that is the end of part 3.